Hi, welcome back to General Chemistry 1. I'm Dr. Fang Xu, and today we're going to talk about activity series. And this is the last topic in Chapter 4. So what is the activity series? For example, here we have different halogens, and they are different. The different halogens have different activities, and together they have the activity series. You can tell from this chart fluorine is the most active halogen element, while iodine is the least active halogen element. So when we have this activity series, we can predict reactions. Usually, the more active elemental substance can displace a less active element from a compound and make a new elemental substance. So what does that mean? Let me show you an example. Here is the equation, chemical equation. Bromine gas can react with sodium iodine to form sodium bromide and iodine. Okay, so in this chemical equation, the more active elemental substance, bromine gas, can displace the iodine from sodium iodide, and then to react and to form a less active elemental substance, iodine gas. And form the bromine now become where the position of iodine is in the sodium bromide. So overall, this is how the more active elemental substance displace the less active element. For this reactions from the activity series, it's a single displacement reaction. It means a chemical reaction in which one element is replaced by another, parentheses, more active element in a compound. A single displacement reaction, as you can tell from here, is a redox reaction. The oxidation number for bromine before the reaction is 0, now it's -1. So it's a redox reaction. If you recall, we also discussed a double displacement reaction. I would like to ask you, is double displacement reaction a redox reaction? Well, if you recall what the double displacement reaction is, they exchange the anions or the cations. So there's no redux there. There's no changing of the oxidation states. It's just different combination between cations and anions. So double displacement reaction is not a redox reaction. Okay, before the activity series of halogens, we can also have activity series of metals. You can tell from this chart, from the top is lithium, potassium, and in the very bottom we have copper, mercury, silver, and gold. The top one is more active than the bottom one. You can see here the hydrogen is marked with a different color background, and usually, like from this chart, this hydrogen is used as a benchmark. All the metals that are more active than hydrogen can displace hydrogen from acid, steam, or water. All the elements below hydrogen, which are less active than hydrogen, cannot displace hydrogen from any source. Okay, as you can see from the top, it also distinguishes these metals, or put these metals into 3 different categories. The most active ones can displace hydrogen from water, which means at room temperature. If we put lithium in the water at room temperature, they will react and give you hydrogen gas. In the second tier, from magnesium to cadmium, they can displace hydrogen from steam, which means if you just put that in the room temperature water, no reaction will occur. But if you heat it up to make the water as water steam, the reaction can occur, and it can displace For example, here zinc can displace the water steam to produce hydrogen gas. In the third category, from cobalt to lead, they can only displace hydrogen from acid. For example, here tin can react with acid to form a hydrogen gas. So all of these three categories, it can be downgraded but not upgraded, which means if we have a lithium, it will also react with water steam to produce hydrogen. It can also react with acid to produce hydrogen. However, if we have a tin and the tin cannot react with steam, cannot react with water, it has to be acid, so it cannot upgrade it. Okay, if I give you a series of if I give you an activity series of metals, I will expect you to be able to predict some of the reactions. Okay. Besides displacement of hydrogen from water or acid, the more like before, the more active elemental substance can displace less active element in a compound. For example, zinc is more active than copper, so the elemental substance zinc metal can react with copper ion, copper cation, to produce zinc cation and copper metal. So this type of reaction, zinc and metal reaction, will be the same, follow the same rules as we described before of halogens. All right, let's try a problem. Now I give you this activity series. Okay, as you can see, zinc is more active than hydrogen. So can this reaction take place? Can zinc react with sulfuric acid to produce zinc sulfate and hydrogen gas? Okay, so here sulfuric acid is an acid, right? You say, oh, I did not tell you which category zinc is. Can't react with steam or react with water or acid, which one? So for this one, since acid is already the most easy materials that can be used to displace hydrogen. So if zinc is have higher activity than hydrogen, then it has to be able to displace hydrogen from the acid. Okay, so in that case, this reaction can occur because zinc is more active than hydrogen. If I ask you if zinc can react with water at room temperature to produce hydrogen gas, then in that case, you need to know which category the zinc is. If you refer to before, the zinc can only react with, can only displace hydrogen from steam. So if I give you zinc and room temperature water, no reaction will occur. All right, this is the end of this video, and I'll see you next time.